Okay. So again, just to kind of recap what we did here for this first example, we have this kind of complicated looking picture with all of these different points. The first part we see if BC is congruent to AB, which two angles are congruent? So BC and AB were these two sides. So that means we're dealing with this whole overall big triangle. And the angles that are across from them are the ones that are going to be congruent. So across from BC is angle A. Across from AB is angle C. So angle A and angle C would be congruent, and that's the base angles theorem. The way that you tell if it's base angles versus converse of base angles is it depends on what you start with. If you start with sides and then talk about angles afterwards, like here we started with sides and then we went to angles, that's the base angles theorem. On the second one, though, we start with angles and then we go to sides, so that's the converse of the base angles theorem. And on the second one, we deal with this little triangle right here because we're told that angle A is congruent to angle ABE, this one right here. So then EA is across from angle ABE, and then EB is across from angle A. So EA and BE would be congruent by the converse of the base angles theorem. So that's one type of question that you'll see today fairly frequently on your assignment. There's 11 questions on our Big Ideas assignment, and at least 2 or 3 of them involve this kind of a picture and pulling out information. Okay. The next kind of problem that we're going to see involves kind of bringing back things like vertical angles and stuff that we learned from earlier chapters and kind of bringing that forward into this. So there's our picture. And we want to figure out what 3x is, or what x is or what x is, so we need to figure out what 3x is so we can set those equal. Okay. And we're given information about the different sides that are equal to each other on these triangles. So, starting here, where we have information that we know, because we always kind of want to start where we have information that we know. Start with what you know. So I know that this is a 30-degree angle, and I know that these two sides are congruent. So that tells me that these two angles across from it, or across from these two sides, are the same. So then this is kind of like what we did yesterday. We can take 180 minus 30. And I know that together, these two angles have to be 150 because all the angles together have to add to 180. So then if I take 150 and I divide it by 2 to split it evenly between these two angles, we get 75. So these two are both 75. Then notice we've got some vertical angles going on here. So these two angles are the same, so this one is also 75. So now we've jumped from this triangle over to this one using our vertical angles. So then we know that these two sides are the same, which tells me that these two angles are the same. So this one is also 75. So now we know 3x equals 75. We can divide by 3 on both sides and get x equals 25. Hey, good to see you, Gerardo. Okay. So there we go. X is 25. Any questions from that example? Any numbers we're not sure where they came from, any steps we're not sure why or how they happened? All right, just because you two don't doesn't mean someone else might not. Okay, so just to kind of reiterate what we did here, we use the fact that these two are the same to say that these two angles are the same. And then just like yesterday, we took 180 minus the angle we know and cut it in half to make these two angles. So these would both be 75 for this one. Then we have vertical angles to bridge over to this triangle. And then we have, since these two sides are the same, these two angles are the same. And so we set 3x equal to 75 and solve for x. Okay. The last example I'm going to show today is probably one of the hardest types of problems that you can get from this type of question or from this concept. So bear with me here. Last example for today. Okay. Okay. There's our picture. From just this information, we are going to find x and y. So it's a fairly busy picture. We have a lot going on, but there's not a lot of numbers in the picture that we have already. So we're going to have to kind of find some numbers for this. So the first thing I would do over here is notice that this is an equilateral triangle. And for an equilateral triangle, what are all of the angles equal to? In an equilateral triangle, what are all the angles? Yes, Brooklyn, 60. So that means that this angle, and this angle are all 60. And since this angle right here is a right angle, and this part of it is 60, that means that this part of it is 30. So we have that this is 30 and this is 60. And then from there, we know that we can find these two angles because these two angles are equal to each other. And we know that this angle is 30. So we can do what we did up here on this one and go, okay, 180 minus 30 gives me 150. And then 150 split evenly between these two angles gives me 75 each. So this angle is 75 and this angle is 75. So now we know that y is 75. That's part of my answer. Okay, from there, I'm going to plug in 75 minus 25 here to get 50. So 50 is my side length. And since these are all the same, that means that this is 50 and this is 50. All right, so we might be thinking, how does that help me get over to x? But notice that these two angles are the same. So then these two sides are the same. So since this one is 50, this one is also 50. So x is 50. Okay. So that one's probably the most complicated one that we'll see involving this sort of thing. So just to kind of go back over what we did, we figured out that since this is equilateral, these are all 60. Then since this is 60, this one's 30, because this is a right angle, so it's 90 degrees total. And since this one is 30 and these two are equal, we could go 180 minus 30 and then divide that by 2 to get these two angles here. From there, we plug that in for y. Y is 75, so 75 minus 25 is 50. That's our side length for all three of these sides. Then, since these two angles are equal, these two sides are equal. So they're both 50, so x is 50. Okay. So that's what we have for examples. For our homework, it's going to be in big ideas today, so we'll go over a couple of the problems out of big ideas as well, for those of you who would like to do a few with me. So if you go to Google Classroom, that should now be posted in Google Classroom. So that's where we're going next. And that's pre-calc, so geometry. And here it is. And it doesn't seem to want to load. For me, anyway. Let's see. All right, well, we might have to go over to my other big ideas tab and kind of go from there. Okay, so problem number 1 in the assignment says, use the figure, and this picture looks a lot like our first examples picture. If AB is congruent to EB, then blank is congruent to blank, angle-wise. So here's AB, here's EB. They're congruent to each other. So that means we're dealing with this little triangle over here. EB is across from angle A. AB is across from angle BEA. So angle A is one of our angles, and BEA is the other one that are congruent because EB and AB are congruent to each other. And then the theorem that you use to find the answer is the converse of the base, or sorry, is not the converse, is the regular base angles theorem, because the base angles theorem says that if you start with sides that are congruent, then you can go to angles being congruent. So that's the base angles theorem. But they both have the letter A. They do. Angle A is talking about this one over here. BEA is talking about this angle here, because remember, the letter that's in the middle is the vertex. The letter that's in the middle is that corner letter. Okay. So let's see. Number 2 is similar. I'm going to leave that one for you guys to do. We're going to jump to 4 is similar. Leave that for you guys. We're going to jump to 5 and 6. Yes, Philip, I will post an exit ticket in just a little bit. 5 and 6 here. So on number 5, this is just an interesting one. If you know that 2 of your angles are 60, yes, you're correct, Adon. What's your third angle going to be? Yeah, also 60. If 2 of your angles are 60, then all 3 of your angles are 60. And then if they are all 60, then all the sides are the same. So just like Adon said, if all the sides are the same, then these would both be 16. Yes, I will post the notes later, Maria. Okay. The next one, though, number 6, we'll talk about. We have a bunch of angles that we know are congruent, and then we have a bunch of sides that we're trying to figure out what goes together, what things can we set equal. So, first off, notice that this is an equiangular triangle. So that also means it's equilateral. All the sides are the same. Which tells me that 5y minus 4 will be the same as 3x minus 5. These will be equal, but that's not super helpful to me right away, because setting something with an x in it equal to something with a y in it doesn't really do me any good right now. I can't solve for anything yet. But that's where we jump over to this second triangle here, because this angle and this angle are the same, which tells me that this side, the 3x minus 5, is the same as the y plus 12 side. So I know that now all three of these things are equal to each other. All three of these are equal. So what I can do then is set y plus 12 equal to 5y minus 4, since all three of these are equal. So I'm going to do that over here. So we add 5y minus 4 equal to y plus 12. So then you would add 4 to both sides to get 5y equals y plus 16. Subtract y from both sides to get 4y equals 16. Divide by 4 on both sides to get y equals 4. All right, so there's part of our answer, y equals 4. Then once I know what y is, I can plug it in to find the side length. So 4 plus 12 is 16. So this whole side here is 16. Then I can set 16 equal to 3x minus 5. Because y plus 12 is now 4 plus 12, which is 16. So then we would add 5 to both sides to get 21 equals 3x. And divide by 3 on both sides to get 7 equals x. So our answer would be 4 for y and 7 for x. Okay, so that's kind of combining a few things there, but there's our answers. So looking at that, are there any questions, any numbers we're not sure where they came from, anything like that? Okay, if you don't have questions at this point or anything you want to work on with me, you're free to go. Make sure that if you are one of those people who has a quiz that is missing, that you go in and finish that quiz. There's still a couple of you out there that have missing quizzes that are really impacting your grades. Otherwise, have a wonderful day.